We are going to solve radical equations, and there is the power rule where it's when you raise both sides of the equation to the same power of the index to clear the radical, you have to make sure you check for erroneous solutions. And then if you're solving a radical equation, you want to isolate one radical on one side of the equation, raise each side of the equation to a power equal to the index of the radical, and simplify. And if the equation still contains a radical term, repeat step 1 and 2, and if not, solve the equation. And then you have to check all proposed solutions in the original equation. So also remember that 2x plus 3 quantity squared means that it's 2x plus 3 times 2x plus 3. The principal square root of a non-negative number is its non-negative square root, and it is impossible for an even root radical to equal to a negative number. And then we'll hit that part when we get to it. All right, so let's look at example. We are solving on these equations. Zoom in just a little bit. So for example 1, we have the square root of 6x equal to 42. So in order to solve this, what we're going to do is raise both sides to the index. Because it's a square root, it is an index of 2. So the square takes care of the square root. We're left with 6x, and 42 squared is 1,764. Divide by 6, and x equals 294. Now, what I was telling you at the beginning when we were looking at the handout is that you have to come over and check your solutions. So what we need to do is plug 294 in for x. And we want to know, does it equal 42? So 6 times 294 will get us 1764 equal to 42. The square root of 1764 is 42. 42 equals 42, so our solution is fine. All right, let's look at example. So let's call this part A. Let's do B. So if we have the square root of 6x equal to negative 18. Very similar problem, but slightly different. So again, we're going to raise both sides of the equation to the square because we have a square root. And we need to clear that index. So squaring that square root takes care of the square root. We end up with 6x. Negative 18 squared gets us 324. Divide by 6, x will equal 54. So now we need to check it. So the square root of 6 times 54, we want to know, does it equal negative 18? Well, 6 times 54 is 324, and the square root of 324 is 18. Now this doesn't work because we have 18 equals negative 18, so our solution is the empty set. There is not a solution. So if you remember when we started out, when we were looking at the handout, I mentioned that the square root cannot equal a negative value. So as soon as you see you have a negative right there with a square root, you will not have a solution. If it was a cubed root, you can, but not a square root. All right, let's look at another example. So if we have the square root of 2x minus 3 equal to 9, again, we want to square both sides. Square takes care of the square root. We end up with 2x minus 3. 9 squared is 81. So 2x equals 84. Divide by 2, and x equals 42. So again, we're going to check. And when we're checking, we're back to the square root of 2 times 42 minus 3 equals 9. 2 times 42 will get us 84 minus 3. 84 minus 3 is 81. Square root of 81 is 9. 9 equals 9. So our solution worked. Okay, let's look at another one. This will be D. We have the cubed root of x plus 1 plus 5 equal to 3. So the first thing we have to do here is get the radical by itself. So we're going to subtract 5 from both sides and get the cubed root of x plus 1 is equal to negative 2. Now that we have the radical by itself, we can work this. Now, it is equal to a negative number, but we're not dealing with the square root. We're dealing with a cubed root. So we are going to cube both sides. So the cube takes care of the cubed root. We're left with x plus 1. And negative 2 cubed is going to get us negative 8. Subtract 1, we get x is equal to negative 9. And then let's go check our solution. So we have the cubed root of negative 9 plus 1 plus 5 equals 3. Well, negative 9 plus 1 gets us negative 8. So the cubed root of negative 8 plus 5 equals 3. We'll subtract our 5 over. Well, actually, we don't need to do that. Sorry about that. We don't actually need to do that. What we can do, we can take the cubed root of negative 8 because it is a perfect cubed. So that'll get us negative 2 plus 5 equals 3. Negative 2 plus 5, well, that's 3. And 3 equals 3. So we are good on our solution. All right, let's look at E. So on part E, we have the square root of 4 minus x equal to x minus 2. So again, we're going to clear our radical by squaring both sides. Clearing the radical with the square, we get 4 minus x. And remember, this is x minus 2 times x minus 2. So 4 minus x equals, remember, we're going to distribute x times x is x squared. X times negative 2 is negative 2x. And then negative 2 times x, negative 2x, and negative 2 times negative 2, positive 4. We'll combine our like terms in the middle, so 4 minus x equals x squared. That'll get us minus 4x and then plus 4. So now we need to move everything to one side because we have a x squared term. So I'm going to subtract 4 and add x from both sides. So this will get us 0 on this side, and here we have x squared. Negative 4x plus x will be negative 3x, and 4 minus 4 cancels. So now we got to look at what we can factor out of this. So 0 would equal to x times x minus 3. Now we'll set each part equal to 0, and then add our 3 over, and x will equal 3. So x equals 0, x equals 3 are our two solutions, but we have to go check and see if our solutions work. Let me zoom out just a little bit so we can see the whole problem. All right, so let's check. So we'll start with the 0. So we have the square root of 4 minus 0 equal to 0 minus 2. Well, 4 minus 0 is 4, equal to negative 2. Square root of 4 is 2. 2 equals negative 2. Oh, well, that does not work. All right, let's check our 3. Square root of 4 minus 3 equal to 3 minus 2. Well, 4 minus 3 is 1, square root of 1. 3 minus 2 is 1. Well, square root of 1 is 1. 1 equals 1, so this one works. So this one is a good solution, and this one is not. All right, let's go look at our next problem. So we have part F. We have the square root of x plus 3 equal to the square root of 2x minus 1. So this time we actually have two radicals, and they're both raised to the second power. So we're going to square both sides to clear our radicals. So we end up with x plus 3 equals to 2x minus 1. Well, I'm going to decide that I want to put my x's on this side so that I have positive x's, and I'll move all the numbers over there. So minus x, we get 3 equal to x minus 1. Add 1, we get 4 is equal to x. All right, so let's check. So the square root of 4 plus 3 equals the square root of 2 times 4 minus 1. 4 plus 3 is the square root of 7. 2 times 4 would get us 8 minus 1. 8 minus 1 is 7. We have square root of 7 equals square root of 7. We are good. All right, let's go look at another type of problem. So we're going to do a Pythagorean theorem problem. So on example 2, we want to find the length of an unknown leg of a triangle. So here's our triangle. We're going to say that's a right angle. I see it's not quite straight. You straighten it out just a little bit. So it's a right triangle, whether it looks like one or not. And we have a 10 over here, x, and a 4. If you recall, the Pythagorean theorem is that a squared plus b squared equals c squared. And c is always across from our right angle. So this will be our c. It does not matter which one's a or b. So I'm going to, let's say this is a and this is b. It doesn't matter. So if we're doing our formula, a squared would be 4 squared plus b squared, which is x squared, equals c squared, which is 10 squared. 4 squared is 16 plus x squared equals 100, because that's what 10 squared is. Subtract our 16 over. We end up with x squared is equal to 84. Now we're trying to solve for x. So we got to take the square root of both sides, and x is equal to the square root of 84. Now usually when we introduce a radical, we do plus or minus. But in this case, we're not going to do plus or minus because we're talking about distance, and distance cannot be negative. So we have made our square root just positive because it can't be a negative distance. Now, this is not reduced enough, so we're going to reduce this down. 84, you could use 2 times 42. I'm going to use 4 times 21. 4 is 2 times 2, and 21 is 3 times 7. So this will be equal to the square root of 2 times 2 times 3 times 7. Looking for a group of 2 numbers that are matching because we're doing a radical that has an index of 2. So the 2 comes out, square root of 21. So our x is equal to 2 square roots of 21, and this would be your answer. All right, now we're going to do a word problem. Word problem is going to also deal with the Pythagorean theorem. We have a 50-foot supporting wire is to be attached to a 75-foot antenna. Because of surrounding buildings, sidewalks, and roadways, the wire must be anchored exactly 20 feet from the base of the antenna. How high from the base of the antenna is the wire attached? All right, so let's go to a different piece of paper. So this is our example 3. And we are looking at an antenna, and we know the distance of the antenna is 75 feet. We also are told that the distance from the bottom of the pole, the antenna, to where the wire is on the ground, we're told that it's 20 feet away. And we're also told that the length of the wire is 50 feet. We don't know how far up, so I've just drawn a picture that kind of shows it. This is what we need to find out. We need to find the x. So again, we're understanding that the pole, or the antenna, is going to be put in perpendicular to the ground. So this is our right angle, so this will be our C, and it doesn't matter which one is A and which one is B. You can choose either one. So we're still using our Pythagorean theorem. So we have x squared, which is our A, plus 20 squared, which is our B, is equal to 50 squared. Well, 20 squared is 400, and 50 squared is 2,500. So we'll move our 400 over to the other side, and we get x squared is equal to 2,100. Well, in order to solve for x, we're going to take the square root of both sides. Now, again, this is a distance, so it's not going to be negative. So we end up with x is equal to the square root of 2,100. So I'm going to pull the square root of 2,100 over here. I know it ends in 2 zeros, so I know 100 is a factor. So I'm going to do 21 times 100. 21 is 3 times 7. 100 is 10 times 10. 2 times 5 for each of the tens. So square root of 2 times 2 times 3 times 5 times 5 times 7. So we're looking for groups of 2 of a kind. I have 2 2s and I have 2 5s. So this will be 2 times 5 times the square root of 3 times 7. So 2 times 5 is 10 square roots of 21. So our x will be equal to 10 square root of 21. Now this is the exact value. If in your homework or the problem they want an approximate, our x would be equal to 45.8 feet. This would be an approximation, or the approximate value, because now you have a decimal instead of a radical.